So today I am going to discuss the sixth problem of Atcoder beginner contest 245. So we are given a directed graph G with n vertices and images, and like UI and VI are given, which represents a directed edge from UI to VI. We have to figure out that if what are the number of vertices present in the graph, which are part of a cycle. Okay, so let me explain you what is the meaning of the sentence. The sentence is Takashi will start at a vertex repeatedly and repeatedly travel on G from one vertex to another along a directed edge. How many vertices of G have the following condition? Takashi can start at the vertex and continue traveling indefinitely by carefully choosing the path. So that means that we can start at any vertex and we can travel on the cycle. So there is like let me explain you. Let's say there is a cycle from 1 to 3 and 3 to 1. So if we start at any vertex of the cycle, like for 1 2 or 3, we can indefinitely travel the cycle. So we have to find out what is the number of nodes which are a part of a cycle. But there is a twist here. The twist is that if there is a node which is not part of a cycle but from which we can go to any cycle, then the node will also count. So here let's say one is not part of a cycle, but we can go to one, like we can go to the cycle 2 3 4 from one. So this node will also count. So what is my approach? Like my approach is quite simple. Instead of finding like what are the nodes in the cycle, I try to figure out what I try to figure out the strongly connected components in the graph. So strongly connected components, that means you can read it in the internet or GFG, that strongly connected component means that in the component we can start from any of the node and we can traverse all the node of the connected component. Okay, so here 2 3 4 are the strongly connected component. We can start from any node and we can travel all the nodes of the strongly connected components. Here also 1 2 3 are part of the strongly connected components. So I try to figure out what is the strongly connected component in the graph, and for any strongly connected component, any node of the strongly connected components, I try to go to the, like, any strongly connected component is a part of a cycle. Okay, any strongly connected component is a cycle, because if we can go to any of the node to any other node of the strongly connected component, it means that we are in a cycle. Okay, I hope you have understood what I am trying to say. So if we these 2 3 4 are a strongly connected component and also part of a cycle. So I try to go, so any node, like any node which can reach the strongly connected component will be our interesting node, or will be a node which we will count. So from one we can go to the strongly connected component 2 3 4. So one will also count. So let me explain you like more, like 1 2 3 4, say 5. We can go to so here the strongly connected component is 2 3 and 4. The strongly connected component is 2 3 4. We can go to 1, we can go to 2 from 1, we can go to 3 from 6, and we can go to 4 from 5. So these three nodes will also count. So the answer for this case, the number of nodes, the required answer will be 6. Okay, so we have to figure out the number of nodes which are part of a strongly connected component. So let me write it. So we have to figure out the nodes which are part of a SCC or nodes. These are the first nodes which are part of a SCC, and nodes from which we can reach the SCC. Okay, reach a SCC. Any SCC, if we reach any SCC from a node, then our answer will be yes. So I hope you know what is the like algorithm. You can use any algorithm, Kosaraju algorithm or Khan algorithm, to find SCC. Now after finding SCC, what will we do? We will figure out what is the node. Like we will mark this node as one. If any node is a part of SCC, we will mark this as one. Now these nodes are parts of a SCC. Then we will traverse in the reverse graph. So I think you know the reverse graph. Reverse graph are the graph where all the edges are reversed. So we will traverse the reverse graph from the node which are marked as one. Okay. So here 2, 3, and 4 are marked as one. So we will go to this node and we will start a DFS and go to the reverse graph. So from 2 we can go to 1, from 3 we can go to 6, and from 4 we can go to 5 by traversing the reverse graph. Okay, so let me show you my code. I hope you will understand from the code. So here I am, like this is the front graph, like this is the original graph, and this is the reverse graph. So in the reverse graph, the age x y will be reversed as y comma x. So here I am doing the normal DFS to figure out, if you if you have any doubt in this code, you can always read the GFG example for finding strongly connected component with DFS. For finding strongly connected component with DFS, we can, after DFS is done, we will push our node, the current node I in the stack. You can read it, this strongly connected component by DFS is very important topic. So here stack S will store the strongly connected components. So after I figure out, I stored the traversal. This traversal is also used in topological sort. So this stack will be like topological sort of the graph. So after storing the topological sort of the graph, what will we do? We will traverse one DFS2. So from DFS2 we will try to mark nodes, in the DFS2 we are storing the nodes which are part of a strongly connected components. So here I am clearing G for before every iteration for DFS2, and in DFS2 we are storing the nodes, if we start from 2, our V value will store 2 3 4. So the strongly connected component will store 2 3 4, and if our length of the strongly connected component is greater than 1, we will marking this node as TRI is equal to 1. That's what I have said, that I am marking this node as 1. Okay, so after this is done, we are doing another DFS on the on the reverse graph. We are doing another DFS on the reverse graph, and we are marking the nodes as visited 1. Okay, so after our DFS is done, now we will, let me write the reverse graph. So my reverse graph will be like from 2. I think this will be my reverse graph. This will be 2 3 4, from 4 to I think 5, and from 3 to I think 6. Okay, so I will these nodes are marked as 1, 2, 3, 4 are part of a strongly connected component, so these are marked as 1. So I will DFS from this. So TRI is marked as 1, so I will do DFS from 2, 3 and 4, and mark all other nodes as 1. So after marking all other nodes as 1, I am just at the end I am storing that if the node current node is visited, then our answer will be incremented by 1. At the end I am printing the answer. I think my algorithm is quite straightforward. I hope you have understood my code also. If you have any doubt, you can ask in the comment section. Please like the video and subscribe to my channel. Thank you.